All right, guys, so we need some practice finding the least common denominator of different rational expressions. So the least common denominator is easy. All it needs is all of the common, actually, it needs every factor that all the denominators have. Here's what I mean. If you look at this rational expression, the first denominator right here has three factors, 2 and k. It's 2 times k times k. The second factor here has 4 factors. It's got 5 times k times k times k. Now don't pay attention to how weird I draw my k's. I know I draw my k's weird. Okay, so I've split all my denominators into all these factors, right? So all I need to do for my least common factor, or my least common denominator, is to pick, just have enough factors that covers all these guys. So here's what I mean by that. If I've got 2 k's over here and I've got 2 k's over here, these are the factors that match between the two factors, okay, or between the two denominators. Okay, so I know that my denominator needs a k times a k. Okay, the other thing my denominator needs is everything that doesn't match too, just one of each of the things that don't match. So I take the things that match between all the denominators, and I just put that down once. I also have to put down everything that doesn't match once. So I need a 2, right? I need a 2 times 2. I need a 5 times 5, and I need a k. There's another k here that didn't match. I need that too. Okay. So how many k's do I have here? I've got 3 k's multiplied together. That's k to the 3rd power. And what are my numbers that are multiplied together here? 2 times 5, that's 10. So my least common denominator, what I'd have to multiply by both sides of my equation, is 10k cubed. Let's try another one here. Okay. So here we've got, this is already kind of factored up. I've got one denominator is x plus 4 times nothing. Well, 1 times 1, I guess. Everything's multiplied by 1. I've got x times x minus 4. So one factor in the first denominator. In the second denominator, I've got 2 factors. X is 1, and k plus, or x plus 4 is another. And then in the third denominator, I've got 2 factors, x times x. Okay? So for my least common denominator, I need everything represented once. I need my matching denominators represented once. So here I've got one matching factor, and I've got another matching factor. Okay, I need each of these matches represented just once. So I'll write x plus 4 once, and then I'll write this x once. Okay, and then I've got one more factor that didn't match. I need that one too. I need that one just once. Okay, so there's my least common denominator, is everything that I had represented up here just once, whether it was matching or not. So I've got, how could I write this more simply? X squared times x plus 4. Because the x squareds become x squared, or the x times x becomes x squared, and x times 4. It doesn't matter what order you multiply in. As long as they're all being multiplied, you can multiply them in any order. Okay, we got 2 more problems left. So let's find the LCD here. This factor this denominator has 4 factors, 2 times x times x times x. This one has 2. Well, it's more than 2 in this case, actually, because 20 can break up, can't it? I can write 20 as 2 times 2 times 5, okay? And we know how to factor that using the little factor trees, right? And then it's also got a times x in it, so that's really 4 factors there. I've got 3 factors in this denominator. I've got 2 times x, okay? And now for my LCD, all I want to do is find matches, okay? So I've got 2 x's here and 2 x's here, okay? I've got 1 here and 1 here. Okay, I've got a 2 here that matches with that 2 and that 2. Okay, so what I've got is a 2 that matches in all of them. I've got an x times x in x times x here. I've got an x here. Everything that matches, I'm just representing one time. Okay. What do I have that didn't match? I've got this 2 and I've got this 5. So times 2 times 5. Now, what are all the numbers multiplied together? 2 times 2 times 5? I have 20. Okay. 20 is my GCF. Or my, not my GCF, rather my part of my LCD. Okay. And then I've got 3 x's multiplied together. That's x cubed. Okay. So 20 times x cubed is my least common denominator for this rational equation. 20 times x cubed. Okay, one more, and then we're done. So, 2 factors here. One of them is 2x minus 1. Another one is x plus 2. Okay. 2 factors here, x and x plus 2. 3 factors here. I've got x times 2x minus 1. Okay. So, what matches? Well, I've got one pair of matching 2x minus 1s, so that's got to be part of my least common denominator. It's 2x minus 1. I have a matching set of x plus 2s, so that's got to be I've got to have an x plus 2. I've got a matching x, okay, so I've got that matching x. And then, what do I have all by itself? Just 1x, so that's got to be in there too. Just 1x. All right. And now I've got, if I multiply it all together, I don't really want to distribute. I want to leave it in its factors, but I can combine those 2 x's. So I can have x squared times 2x minus 1 times x plus 2. Okay. So the point of finding the least common denominator, the point of finding all of these least common denominators, is to find the smallest expression that all of the denominators in your equation could multiply evenly into. Okay? There's other bigger expressions that they could all multiply evenly into, but this is the smallest one. So I could divide this denominator evenly into this expression. I could divide this denominator evenly into this expression, and I could divide this denominator evenly into this expression. And the reason we want that is so that when we multiply this expression by everything, by both sides of the equation, all our denominators will cancel. That's the whole point, is to figure out how we can multiply something that will make all our denominators go away.